Here's the reading of pages 13 through 15, and we're going to start with locating ourselves in space, grid lines. We're almost ready to begin our odyssey through time and space, but first we have to be sure we can locate ourselves on the Earth's surface. We'll need another reference system for that. You've probably used a road map to find a city or some other place. Most road maps have lines that run north, south, and east, west. Those crisscrossing lines make a grid. The lines are called grid lines, and maps with grid lines on them are called grid maps. The grid lines divide the map into sections and make the map look something like a large checkerboard. The spaces between the lines are numbered or lettered. The numbers help us find cities according to their east-west location. The letters help us find cities according to their north-south location. Together, they give us reference points that help describe the location of any place on a grid. For example, on the grid map in Figure 5, Oak Bluff is located at C3. So here's Figure 5. Here's those letters, A, B, C, D, and then 1, 2, 3. So if we go C, so this is north and south, and then this would be east and west. C would be right here, and then 3, Oak Bluff. So that helps you find that. On the grid map in Figure 5, what is the location of Central City, of North Rapids, of East Central City? And we'll do that during class. Locating ourselves on the globe, longitude and latitude. We can use a similar grid system to find points on a globe. Let's start with the imaginary line known as the equator, which runs around the Earth halfway between the North Pole and the South Pole. So here's the equator, here's the North Pole, here's the South Pole. As you may already know, the equator is in equal distance from each of the poles. See Figure 6. So it's the same distance from the equator to the North Pole as the equator to the South Pole, even though it doesn't look like it in this picture. When you hold a globe and look straight down on the North Pole, you can see most of the northern hemisphere. If you look toward the equator from the North Pole, you'll see that the circles running around the globe get larger as they get closer to the equator. We call these circles parallels of latitude. So see how these look kind of smaller and then they seem to get bigger as you get to the center? Those are lines of latitude. All points along a parallel are the same distance from the equator. The parallels tell how far north or south any given point is from the equator. Okay, so these are all the same distance. We use the parallels as reference lines. Each parallel has its own number from 0, the equator, to 90 on each pole. So from the equator it goes 0 and then all the way up to 90. Okay, or down to 90. Its numbers tell how far north or south it is from the equator. So again, 0 is at the equator. Now look at the globe again, and you'll see a second set of lines that cross the parallels. Rather than running east and west, as lines of latitude do, these lines run north and south. They divide the globe into sections like an orange. The lines are called meridians. Okay? If we label one of these meridians 0, we can use it to tell how far east or west we are. We do that by simply counting how many meridians east or west of the 0 meridian we are. The meridians are called the lines of longitude. So you can see Figure 7, and the one that's 0 is prime meridian. We saw that the parallels are numbered from 0 to 90 north and from 0 to 90 south. Okay, remember up and down? The distances north and south of the equator are called degrees of latitude. The distances east or west from the 0 meridian are also called degrees, but they are degrees of longitude. The lines of longitude run from pole to pole. So 0 meridian is also called the prime meridian. There are 180 degrees of longitude west, and there are also 180 degrees of longitude east. So if you go this way, you go 180. If If you go this way, you go 180. So this is west, and then this is east. These intersecting lines of latitude and longitude make a useful grid system to help us find any point on the globe. We can take the same system and use it on flat maps of the Earth as well. Look at the picture of the globe in Figure 8. Which lines are the lines of latitude? Which lines are the lines of longitude? What does parallel mean? Why are the lines of latitude called parallels? Look again at Figure 8 and you'll see the prime meridian. Now pick up your globe and find the prime meridian there, if you have one. On your globe, put your finger on latitude 35 north. Okay, so you'd go up to 35. That would be between these two numbers. And longitude 40 east. So from the prime meridian, you're going to go east to 40. And this is part of the area called the Middle East. So if you look at Figure 9, you can see the same place on the map. Okay, the Middle East is right in here. And then we're going to do these in classes too. The city of Baghdad is closest to which of these 4 locations? Okay, so Baghdad, if you look, is at about 33 degrees north and of the equator. And then east, it's about 45 almost. Okay, 44. So this is the closest one. Look at a globe again. What major city of the world is located near 3030? Now locate that city on the map on page Figure 9. Okay, 3030. So here's 30, here's 30. Right there, Cairo. Look at the globe or the map of the United States. Which of these 4 cities is located at about the same latitude as Baghdad? New York, Chicago, New Orleans, Los Angeles. And you've got pages in the back of your book. Okay, let me see. I think it's page 624. Okay, yep. So Baghdad was right in here at, was it 30 degrees? Okay, 33 degrees and 44 degrees. So right in this area. And if we go across, what latitude? Okay, so right, where are we? 33. So right in here. So let's go back to that page. Okay. So New York, New Orleans, Chicago, or Los Angeles. And that one, see if you can figure that out. Now you know how to locate yourself in both time and space. With that information and with a bit of healthy curiosity, you're ready to begin the human odyssey. And we'll go through this a lot more in class. Now also imagining the past. Nothing helps us understand the past quite like good stories. Maybe that's because history is the great ongoing human story, one made of countless smaller tales of adventure, struggle, and triumph. These stories whisk us across the ocean and ages and sweep us over continents and centuries. They help us see in our mind's eye what happened long ago. They let us put ourselves in the place of people long ago, walk around in their shoes for a while, and glimpse what they might have seen and thought. In this book, you'll find lots of stories, including some stories in special sections called Imagining the Past. Some of these stories are myths important to an ancient civilization. Other stories in Imagining the Past sections are fiction, but they are based on historical truth. Sometimes they involve imaginary characters and likely historical situations. Sometimes they depict real historical figures whose exact thoughts and words may be lost, but whose thinking we can imagine based on the evidence we have. As you read these stories, let your mind travel back through time. Pretend for a moment that you're there, standing beside these characters, living as they might have lived. Spend some time in their world, look around, live their stories, imagine the past. That's one way to bring history to life. And that's the end of the reading of pages 13 through